Hey traders! Introduction to exporting MZPAC indicators data for machine learning. In modern algorithmic trading, machine learning, ML, plays a critical role in discovering patterns, optimizing strategies, and enhancing decision-making processes. MZPAC, a powerful suite of order flow and footprint indicators for NinjaTrader 8, offers deep insights into market microstructure, making it an ideal source of features for training machine learning models. To harness the full potential of MZPAC data in ML workflows, developers and quantitative analysts can use the MZpack API to programmatically access and export indicator data. This includes structured information such as footprint chart metrics, volume delta, bid-ask ladders, speed of tape, order flow events, icebergs, sweeps, large trades, market-generated levels, value areas, POC, custom signals based on stacking or clustering logic, and more. By exporting this high-resolution tick or bar-level data to a format suitable for ML, for example CSV, or directly into in-memory data structures, it becomes possible to build predictive models that learn from historical order flow behavior. To illustrate this process, we will use a basic lightweight sample strategy included with the MZPAC Strategies product. The sample provides a practical foundation for understanding how to access indicator data for machine learning. It also serves as a template for building more advanced data export. Add sample export strategy to a chart. From MZpack API Samples folder, choose Export Indicators Value Strategy, then click Add button. You can export either historical or real-time indicator values. When exporting historical data, the entire interval currently loaded on the chart will be exported. Base directory. By default, the export base directory is located inside the MZPAC folder within the NinjaTrader data folder. The full export path includes the strategy's namespace and name, ensuring uniqueness for each strategy. You can customize the base directory if needed. File naming. You can specify the output file name here, including an optional subdirectory path. If left blank, a random alphanumeric file name will be generated automatically. This sample strategy provides only minimal configuration options. Exported values are hard-coded to keep the example straightforward and easy to follow. Enable the strategy to begin exporting data. The log will display the number of exported rows and the names of the generated files. By default, a header row is included, and each row contains a timestamp. In this example, data is exported with bar granularity, meaning one row per bar. Note that the TPO POC value is initially 0 because TPO profiles were not enabled. Let's enable them in the indicator settings and export the data again. Now the exported file includes valid TPO POC values, Exporting real-time data. Now let's export some real-time indicator values. Set the temporality to real-time. Enable the strategy. Once the necessary data has been exported, disable the strategy. In this example, 6 bars were generated in real time, resulting in 6 corresponding rows written to the output file. Reviewing the strategy code. Let's take a look at the code used in this sample strategy. By default, all samples can be found in the API samples folder located in your MZPAC installation directory. I'm using Microsoft Visual Studio Community Edition, which is free to use and well-suited for development. To compile the sample in NinjaTrader 8, remove if API sample with end if preprocessor directives and add reference to MZPAC NT8 Pro DLL. The strategy class is named Export Indicators Values. In the Create Indicators method, we create instances of MZFootprint and MZVolumeProfile indicators. We also enable saving and loading settings via an XML file. In the setDefaults method, we define default strategy parameters. Set enable backtesting to true to allow the export of historical values. Other default settings are optional and can be adjusted as needed. In the state.configure block, we retrieve indicator settings from the XML configuration. These 2 lines are used to reduce loading time. In the state.dataLoaded block, we create indicator export objects. We pass the strategy instance, the indicator, and other parameters to the constructor. For the footprint indicator, level 1 data is required. We then configure the export parameters. Export temporality is set via a UI parameter. Export granularity is set to bar in this example. Export args includes isFile equals true, base directory and file name from UI, delimiter, isTime equals true, to include timestamps, isHeader equals true, to include column headers. Next, we define the export schema using data schema and specify which indicator values to include. The indicator values are hard-coded for simplicity. Once the schema is defined, we register the export. Repeat the same process for the volume profile export object, specifying a different set of values in the data schema. Of course, you can also use UI parameters to dynamically select which indicator values to export. Here's a basic example of how that might look in code. This simplified example demonstrates how MZPAC indicator data can be exported for use in machine learning workflows. While the sample strategy uses hard-coded values for clarity, it provides a solid foundation you can extend and customize to fit your specific needs. With access to detailed order flow metrics and the flexibility of the MZpack API, You can begin building data-driven trading models with real market insight.